In this video, I'm going to go through question 11 from the 2013 exam. The first thing we'll note here is just that this and this should actually be greater than or equal to signs. This was a typo in the original version of the exam. In this video, I'll work with the correct one. This question is intended to be worked through quickly. You don't have to show any working, and you don't have to perform any algorithms. The two crucial things here to remember are, 1, when to introduce slack variables, and 2, when to introduce artificial variables. The first part is pretty straightforward. You have 1 for every constraint in the problem. For artificial variables, you have to do a little bit more thinking. We have 2 possible forms of constraints that will introduce an artificial variable. One is of the form as follows: a1x1 plus a2x2 plus so on and so forth up to a n xn is greater than or equal to b, where b is positive. This is equivalent to the other form that we'll be looking for, which is a1x1 plus ... plus an xn is less than or equal to a negative number. I write b positive here because we've included the negative sign there. So, to answer this problem for the primal problem, we just have to look at what's on the screen. So for part A, we have 2 constraints, and so we have 2 slack variables. We have 1 constraint, the second one here, which is of the second form included in the artificial variables part. And so we're going to include 1 artificial variable. For part B, we have 2 constraints, and hence we have 2 slack variables. And both of our constraints are of one of the 2 forms shown here. And so we introduce 2 artificial variables to this problem. Finally, for part C, we have 4 constraints and hence 4 slack variables. And we have 1, 2, 3 constraints of the form that introduces artificial variables. So we have 3 artificial variables. To count the number of slack variables in the dual problem, we have to know how many constraints are introduced. This is easy. We just count the number of resource variables in the primal problem. So, for part A, we have x1, x2, and x3. Each of these resource variables will introduce another constraint to the dual. The same thing applies to part B. We have x1, x2, and x3, and so we have 3 slack variables in the dual problem. And again, part C has x1, x2, and x3, and so we'll end up with 3 slack variables in the dual problem. To count the number of artificial variables, we have to be a little bit more cautious. For one thing, it will be affected by whether we have a maximize or a minimize problem, and we have to look at the coefficients of the objective function. When we transform our primal problem into the dual problem, we end up with something on the left-hand side greater than or equal to something on the right-hand side. This is how it always works out. So what we really only need to know is what appears on the right-hand side. And this is only affected by the objective function. So for part A, our objective function is really 0x1 plus 2x2 minus x3. So our constraints would be of the form something greater than or equal to 0, something else greater than or equal to 2, and something else greater than or equal to minus 3. 0 is not a positive number, so this one does not count as one of the forms that we need. 2 is a positive number, so that is one of the forms that introduces an artificial variable. And minus 3, if we rewrote this constraint, would be something less than or equal to 3, so this one is not going to introduce an artificial variable. So we only introduce one artificial variable for the dual of part A. For part B, we have to be careful because we have a minimized problem. This gets adjusted to a maximized problem. So we would be maximizing minus 5x1 plus x2 plus 3x3. So in order to count the number of artificial variables, we have to know how many positive numbers are going to appear on the right-hand side when we form the dual. This is exactly the same as the number of positive numbers that appear in the objective function when it's written in the maximized form. So for part B, we just have to count the number of positive coefficients in the objective function. We've got here 1 for x2 and 1 for x3, and so we're going to introduce two artificial variables in the dual problem. So now finally, for part C, it's already of the form maximize, so we just need to look directly at the formula. We've got one positive coefficient here, one negative one here, and one negative. We'll only be introducing an artificial variable for each positive coefficient, and so we get one artificial variable in the dual for this problem. And there we have it.